Hello, this is Dr. Han. We're going to start Chapter 6. And Chapter 6 is about electrical and electromechanical systems. And we're going to cover from 6.1 to 6.6 from the textbook. So electrical elements consist of either active elements or passive elements. So active elements are such as a voltage or the current sources. The voltage source will be denoted like this, okay, with a V, with a plus and minus. So current wants to flow that way, okay, coming out of the positive terminal and going to the negative terminal. And the current source will be drawn, using a similar symbol, with except you have an arrow with the I. Yeah, so that means it's a current source. And then we use three passive elements, and one of them, the first one is a resistor. Okay? Resistance, denoted as R, okay, has a unit of ohms with the Greek letter omega. And capacitors, denoted as C, okay, is measured in farad. So farad is same as coulomb per volt. So the C right there is the unit of the charges. And the last element, inductors. Inductance is denoted as L. Okay? It's measured in Henry, H. Okay? So resistor will look like a spring. Capacitor will look like two plates. And in the inductance, it looks like a coiled spring. And we have a DC power source, okay? The battery. And then have the long bar and a short bar. Long bar side is a positive side, and short bar side is a negative side. And then this is the ground, and the terminals, if you want to measure voltages across some element, then you use terminals. Yeah? So three equations you have to remember. Yeah, actually, there's more than that. The first one is V is equal to IR. So this one you have to remember, this is a voltage drop across the resistor equals the I. Okay, I through the resistor and the resistance of the resistor. Yeah? Don't forget, you can't take just any current or any voltage. So similarly, the voltage drop across the capacitor is equal to the charge divided by capacitance. Yeah? Where the charge, where the dq over dt is defined as the current. Okay? So sometimes I use current with a capital I, and sometimes I use small I. I really should be using small I, but sometimes I want to use di over dt, okay, di over dt, and this will look a little funny, okay, with a dot on top of another dot. So sometimes I just use the capital I to mean it's a function of time instead of S domain. The voltage drop across the inductor is proportional to the L, but proportional to the rate change of the current with respect to time. So that means if the current is constant, there will be no voltage drop across the inductor. Okay. And then there's actually one more equation that's missing that we may use. That's the power dissipated. This is in watts. This is measured in watts, which is same as joule per second. Okay. It is the voltage times the current. Voltage times the current. Okay, let's go to the next slide. So when you model the circuit, we use two laws by Kirchhoff. The first law is the junction law. This is the Kirchhoff's first law. Okay, this has to do with the conservation of charges. What it says is if you have a junction, you have all these wires coming out of it. Okay. Whatever the current, the sum of the current that goes in, okay, is same as the current that goes out. So let's try this. So let's say you have a I1, I2, I3, and I4. Okay. So in that case, the current that goes into this node, okay, I1 plus I3 must be equal to I2 plus I4. Okay. This is the junction law. And the second law is the Kirchhoff's voltage law that has to do with the conservation of energy, or it's called the loop law. So what's a loop law? Whenever you go around the loop, and whenever you go around the loop, the voltage, the voltage gain must be exactly equal to the voltage drop. So let's say you have a Vs plus minus, the current flows this way. So there's a current direction, assume the current direction, and the loop direction. So if you have, let's say you have a current I1 through R1, you have a current I2 through the resistor R2, okay, and then let's say you have a total current I3, okay, I3. So if you take a loop, okay, if you take around the loop, the total, okay, the loop one, okay, what it says is that the total, the voltage gain, summation of the voltage gain must be equal to 0. Okay, so if you lose voltage, you'll count it as a negative gain. So let's try that one. So you have a Vs, that's a gain. Whenever you go through the negative to positive terminal of the voltage source, you gain. Okay, and then whenever you go through the resistor in the direction of the current, you lose. So you have R1 times I1. So that's how much you lose. That must be equal to 0. Okay. Another way to write the loop law is, let me see which color should I use? How about a purple? Okay. Another way that I like to think about is the voltage gain, okay, due to the voltage source must be equal to voltage loss, okay, in all the passive elements. Okay. For example, in this case, it will be Vs will be on the left hand side. So this is still the loop direction, counterclockwise direction. The green arrow is same as R1 times I1. Okay, so this is my preferred method of writing this. Okay. So when you write the voltage drop, okay, so what people do is they put a terminal here. They put a terminal, okay, and you indicate positive, negative. So this will be, let's say, V1, which is also equal to V2. Okay, V1 is the voltage drop across the resistor 1, and V2 is the voltage drop across the resistor 2. Okay, since they're parallel, they're the same. And this V1 becomes a drop because of the way we write a plus and minus. We put the plus in the opposite direction of the voltage source. Okay, let's take a little break, and I'll see you in the next video. Where's the stop? So now let's do an example. Let's analyze resistors in series and resistors in parallel. So resistors in series are the resistors that, look at, you have a start of the resistor, you have an end of a resistor, and then another one starts right away and it ends. Okay? And you have a voltage source, Vs, plus and minus. That means current wants to flow this way. Okay, you have an I. So using the junction law, yeah, there's only one loop. There's no place for the current to go. Okay, so the total current I that's coming out of the voltage source is going to through the resistor 1 and resistor 2. Okay, so now, so let's see, your I1 is equal to I don't know what that is yet. We don't know what that is yet. Okay, I2 is also equal to I. Why? Because there's no other place for the current to go to. So when we use the loop law, okay, so this one is from junction law. Okay, and the loop law says, whatever you gain, okay, I like to start from the negative terminal of the voltage source. When you start from here, my loop direction will be this way. Okay, that's what I decide to do. Okay, I start from here and I gain. Why? Because I went through the voltage source. So you have a Vs equals, now on the right hand side, I can write down all the voltage losses, which is equal to voltage loss over the resistor 1 and voltage loss over the resistor 2. Okay, and we do know that voltage drop across the resistor 1 is equal to I that goes through it, which is I1, times R1. But we do know that this is also equal to just the total current I times R1. Yeah? Similarly, you have a V2 equals I2 times R2, which is equal to I times R2. Yeah? We can plug in these two into above equations, and we will have I times R1 plus R2. Okay, so now our goal is to replace, replace the 2 register with the 1 register are equivalent. Yeah, when we do that, we should have the same current as we had before. So what I mean is this current right here is same as this current right there. So from this system, we have a voltage source is equal to I times R equivalent. So what we do is we compare these two equations and find that R equivalent must be equal to R1 plus R2. Okay? So the resistors in series, they add. Yeah, you can just add them together. R1 plus R2 is going to be your equivalent resistance. Now let's take another break. So here, one more thing we should consider is the voltage ratio. The voltage ratio between V1 and V2. Ooh, let me make them a little bigger. Okay. Your V1 over V2 is I times R1 divided by I times R2. Okay, and I's cancel. So it says voltage drop has to be proportional to the resistor values. So what does that mean? We have two equations where it says they have to add up to the total source voltage, yeah, and then they have to split in a way that they're proportional to the resistor values. Yeah. So these two equations give us something we can use for a shortcut. For instance, if I give you Vs, let's say this is 9 volt plus minus. Let's say you have a resistor 1 and resistor 2. Then we make up some numbers. How about 200 ohm and 100 ohm? Okay. So we can quickly find the voltage 1, the voltage drop across the resistor 1, which is 200. This is, let's call this one R1, and this is R2. So V1, yeah, plus, yeah, V2, and must be equal to 9 volt. Not only that, V1 over V2 must be equal to 200 divided by 100, yeah, which is 2 to 1. Okay, so we can do this really quickly. What is the voltage drop across the resistor 1? We can use 9 volt, which is a total, and what you do is you want to split this into 2 to 1 ratio. So what that means is you break it up into 3 different parts, okay? And V1 gets 2. V1 gets 2, which is a 6 volt. And do the same thing. V2 is 9 volt, the total, times it gets 1 out of 3 pieces. That means you get 3 volt. Okay? And then I did all this without ever finding the current. So if you want to find the current, yeah, we approach what's the equivalent resistance. So what we do is in our head, at least, yeah, or just draw it. Yeah, we're going to simplify this into a problem with the 1 resistor, our equivalent, which is 300 ohm. We have a 9 volt. Yeah. So we can find the current from this circuit, because current coming out of the voltage source must be equal to the current coming out of the voltage source in the equivalent picture. So now you have a V 9 volt, because the only equation I remember from taking circuits was V is equal to V source is equal to I times R equivalent. So you have a 9 volt equals I times 300 ohm. That gives us I is equal to 9 volt divided by 300 ohm. Wait a minute. 0.03 amp or 30 milliamp. Okay? So this is a total current, and then this is the current that goes through each resistor. So we can check our answer. What is a V1? Let's check. Okay, let's check. What is V1? V1 is equal to I that goes through the resistor times R1. I is 30 milliamp, 0.03 amp, times 200 ohm. That's equal to 6 volt again. Yeah, which agrees with our previous answer. Yeah. So this procedure right here. Okay, this is called the voltage divider law. Yeah, you can write this as your V1 is equal to your total V source times total resistance, which is R1 plus R2 in the denominator, and then you have R1 in the numerator. Yeah? If you want to find V2, this is equal to Vs times R2 divided by R1 plus R2. Yeah? You can think of this term right here, Vs divided by R1 plus R2, as the current in the system. Okay? Where Vs divided by R1 plus R2 is the current. Okay? But when we use this equation, we don't ever have to find the current unless you want to. So now let's consider resistors in parallel. Okay? I want to point out one thing, that this is really useful. Just studying a circuit with the resistors is very useful in our studies when we have capacitors and inductors later, because we're going to take Laplace transform of the whole circuit, and everything will become impedance, which can be treated as if they're resistors. So let's see the resistors in parallel. Consider you have a Vs, the source, plus minus. Okay, let's say you have two resistors. Okay, why are they parallel to each other? Don't even pay attention to the fact that this is 90 degrees, because in real circuits they don't have to be 90 degrees. They're parallel because their starting point, okay, the one end of the resistor, they're tied together, and another end of the resistor, okay, they come together at another point. So this is your R1. Let's say this is your R2. Okay? And then you have a total current coming out of VSI. Okay? But they have to split. Okay? I1 to I2. Okay? What rule did I use? I just used the junction law. So junction law says, okay, whatever the current that goes into the node has to be the same as the whatever that's coming out of the node. So you have a total current is equal to I1 plus I2. Okay, and the voltage law says, I meant the loop law. The loop law says, okay, the loop law says, whenever you go around the loop, okay, the voltage gain has to be equal to the voltage drop. So you have a Vs for the gain. I'm taking this loop. This is your loop number 1. So this is loop number 1. And this will be my loop number 2. This will be 2. Okay. So for the loop number 1, I'm starting from negative terminal of the battery. Going from negative to positive, I gain. So that's why it is Vs. And as you go through the R1, and with the current direction assumed to be positive downward, okay, I lose R1 times I1. That's how much you lose. And then note, because the loop direction is the same as the current direction, I have a positive number here. Okay, I have a positive loss. In the loop 2, you have something similar. Vs is equal to R2 times I2. Okay, what that means is your Vs is equal to R1 times I1 equals R2 times I2. Yeah, they're all the same. Now what we're going to do is we're going to solve for the i's. I1 must be equal to the source divided by R1, and I2 must be equal to Vs divided by R2. And we're going to substitute back in here. Okay. Then we have the total current is equal to the source divided by R1 plus source divided by R2. Okay. Then what we're trying to do is we're trying to come up with a single resistor, the equivalent resistor that can replace the both. So you should have exact same current that's coming out of the voltage source. Okay. So according to loop law, you'll have a Vs must be equal to I the total times R equivalent. Okay. So what do these two circuits have in common? The source and the I. So now we're going to solve for I. I is equal to Vs divided by R equivalent. When you compare these two equations, you have Vs divided by R equivalent must be equal to Vs divided by R1 plus Vs divided by R2. So this must be some equation you must memorize at some point. Whenever you have a parallel resistors, they add like this: 1 over R1 plus 1 over R2 is equal to 1 over R equivalent. If you have two resistors, you can write R equivalent is equal to the product of the two divided by the sum of the two. Okay, and I want you to I want to point out this is only true for two resistors only. Okay, if you have three resistors, this will not work. Okay, for example, you should try. Okay, try 1 over R equivalent equals to 1 over R1 plus 1 over R2 plus 1 over R3. What is this? This is when you have three resistors in parallel. Okay, how do you combine that into one resistor? Okay, that has a value of R equivalent. You will see this is not equal to product over sum. Okay, instead you can show this is equal to let me see, do I really need to do all that math? I think I could. It's going to be R1 times R2 times R3 divided by, let me see, okay, it's going to be R2 times R3 plus R1 times R3 plus R1 times R2. Okay, so definitely this is not product over sum. So I want you to note in our original two resistor system, the current did split. Okay, so you have a R1, R2, and you had a V source plus and minus. Okay, minus. The current did split into I1 and I2. Okay, how do they split? You can go back to this equation right here. Okay, just right here. Okay, right here, and you can find out I1, okay, I1 divided by I2 is equal to 1 over R1 divided by 1 over R2. Okay, they split in a way that's inversely proportional to their resistor values. Okay, and then also your total current I1 plus I2 must be your total current. They have to add up to the total. So let's do an example. For example, let's say you have a source. Let's go back to black. And let's say you have a source Vs, which is, should I do 9 volt again? Let me think. How about 12 volt? Because that's divisible by so many numbers. So 12 volt. And let's say you have R1, which is, which one should I do? How about 100 and 300? Let's say you have a 100 ohm. You have a 300 ohm. Okay, so our goal is to find the voltage drop across each resistors, which is easy. That'll just be 12. You gain 12 every time you go around the loop. You have to lose 12. Okay, you have to lose 12 coming from here to here. You also have to lose, when you go around this loop, you also have to lose 12 volt. So that one is easy. So then I want to find the current through each resistors. Okay, so let's say you find current through each resistor. Okay, the fastest way to do it is combine this system. Okay? To combine this system, combine the resistors as a one resistor, plus and minus, combine it to one. Okay, Req. Okay, rather than proving this all over again, we can say R equivalent is equal to 1 over 100 ohm plus 1 over 300 ohm, and do not forget to invert it again. Okay, so this is equal to, let's see, 300 what is this? Is it 3 plus 4? Okay, here we go. Okay, 4 invert. Okay, invert again. So this is equal to, let me see, what's 3? Is it 75? Here we go, 75 ohms. Yeah, 3 divided by 4 is 75, or 0.75. So you have 75 ohm as an equivalent resistance. So now first figure out what the total current is. So you have a Vs, which is equal to 12 volt. And you have Vs is equal to I times R equivalent. So you have 12 volt is equal to I that we're looking for, and 75 ohms. So your total current is equal to 12 divided by 75 amp. Okay? Let me see. I think this one simplifies. 3 goes into it, maybe. Yeah. 4 divided by 25. No, what's this? 0.16. 0.16 amp. Okay, 0.16. Let me use my calculator. I might as well do the other one too. 100 inverse plus 300 inverse. Invert the whole thing. See, I didn't mean that. Yeah. And invert the whole thing. I get the 75. This is correct. Okay. And then you have 12 divided by that, which is 0.16 amp. Okay. I'm good to go now. So the current number 1, okay, I1 and I2. Okay, the fastest way to is just use them, just divide the 6.16 amp. You have I1 is, okay, your I, the total times you're gonna have the ratio. You're gonna have 1 over R1 plus 1 over R2, and you get the 1 over R1 for the I1. Okay. Or the easy way to do it is, why don't we just split into 1 to 3 ratio, but I1 gets a 3 and I2 gets 1. Okay, so you'll get, this is equal to 0.16 amp, okay, times, these numbers will end up being, okay, 4, you break into 4 pieces, you have 100 and 300, so 4 pieces, and I1 gets the 3, okay, out of it. Okay, so that'll give you 0.112 amp. Let's see. And I2, okay, at this point you can do subtraction. You can do, the total was 16.16 that goes into that node, and then 12.12 comes out of, goes through 100 ohm resistor. That means I2 must be I minus I1, or you can do the ratio too. So that's equal to 0.404 amp. Okay, or I could have just done, I, the total times 1 out of 4. Okay, so which is 0.16 amp, 16 amp times 1/4 is equal to 0.04 amp.